Okay, so we're now going to look at two concepts. One is called relative atomic mass. So AR stands for relative atomic mass. Simple terms, this is the mass of an atom. So we've already looked at this quite a lot, but you can think of it more simply as the mass of an atom. So fancy term for it is relative atomic mass. And then MR, which is relative molecular mass. So sounds fancy. Think of it more simply as mass of a molecule. So one of them we've got mass of a molecule, and the other term is mass of an atom. So if we pick an atom, let's do phosphorus. So phosphorus is P. If we look for the symbol on the periodic table, 15 and 31. So 15, 31. Just to keep ourselves practicing, let's do protons, electrons, neutrons. So protons, 15, electrons, 15, 31, take away 15 gives you 16 for neutrons. So the AR is the relative atomic mass, or the mass of the atom. It gives you it on the periodic table. So relative atomic mass, top number. So for this atom here, AR is going to be 31. So it's literally just a case of looking at the top on the periodic table. So for aluminium, it's 27. For boron, it's 11. For carbon, it's 12. So that term there is giving us the mass of the different atoms. The bit that takes a little bit more time is relative molecular mass, so mass of a molecule. So let's imagine I've got H2O, so that's water. What is the relative molecular mass of a water molecule? Well, it's got two hydrogen atoms in it and an oxygen atom. So a hydrogen atom has a mass of 1, so 1. We've got two hydrogen atoms in it, so what on earth have I done there? 2 times 1. So 2 ones for the two hydrogen atoms. We've also got an oxygen atom which has a mass of 16. So 2 times 1 plus 16 gives us 18. So the mass of the molecule, or the relative molecular mass, MR, is 18 for H2O. Do a couple more examples. AlF3. So I've got Al and I've got 3 Fs. Al is aluminium. It has a mass of 27, so 27 plus, and I've got 3 Fs, 3 fluorines, each has a mass of 19. So 3 times 19, what's that, 27, 57, 84? I think it's 84, let me check that. Could be wrong. No, we're good. So the MR of that molecule there is 84. So that's the mass of the molecule is 84. They can make it slightly more complicated, so let's do a slightly more complicated one. Let's do one of these ones with brackets. So NH4, close brackets 2, so there's 2 of all of that stuff in there, and then SO4. So nitrogens, I've got 2 nitrogens, each have a mass of 14, so 2 times 14. Then I've got 2 times 4 hydrogens, which gives me 8. Each of the hydrogens have a mass of 1, so plus 8 ones. So I've done everything in the brackets. I've done the 8 hydrogens and I've done the 2 nitrogens. I've got 1 S, so an S has a mass of 32, so there's the S, 32. And oxygens have a mass of 16, and I've got 4 of them, so 4 times 16. I'm going to try and do that in my head, so add that up. Gives you 132. So the MR, or the relative molecular mass of that molecule, is 132. Okay, so if we go back to the periodic table now, try and work out what we've learnt about it. we know that the bottom numbers tell us how many protons we have. So if I pick a slightly different example to the one I've always picked, if we do sulfur, I know sulfur's got 16 protons because that's the bottom number. I know because it's an atom and they have no charge overall, it's also got 16 electrons. And then if I do the top number, take away the bottom number, which would give me 16, I know that's also got 16 neutrons. I can do that for literally any atom on this periodic table. So that's one thing we know. We've also talked about the fact that it's arranged in order of increasing number of protons. So you can see the bottom numbers 1, 2, 3, 4, 5, 6, 7, 8, and so on. So as we go across and down, the number of protons goes up. So this atom here, 86, 222, it's got 86 protons, 86 electrons, and then 222 minus 86 gives us 136. That's how many neutrons it's got. So save us having to draw it all out. We've got these little symbols to help us remember. And then you've got the idea, so these are new ideas now, that each of the elements is put into a group. So you can see here, you've got groups. You've got group 1, which are all of these guys, group 2, which are all of these, group 3, group 4, group 5, group 6, group 7, and then this is called group 0 on your periodic table, or you can call it group 8. So the columns are in groups, and then you've also got, I'll just get 1 second. You've also got periods then, so periods are the rows, so if the groups are the columns, so group 1, 2, 3, 4, 5, 6, periods are the rows. So you can see period 1 is this row here, you've got hydrogen and helium in it. Period 2 would be this row here, so starting with lithium and going across. Period 3 is sodium and going across. The reason why they're put into groups is because all the elements in a particular group will react in quite a similar way. So that these all react with water in a very similar way, which you'll see in a later topic. These guys, so these are known as the halogens, they all react in a similar way as well. So we've got groups because they all react in a similar way, and then you've also got the rows, which are the periods. So if we were to say, find the atom, what atom is in group 3 and period 4, we'd have to, so looking for group 3, period 4, group 3, and then hydrogen and helium, so this is group 3, going down, hydrogen and helium are in period 1, this is period 2, period 3, period 4. So the element that's group 3, period 4 would be gallium. So this one is gallium. Let's do one more example of this. So let's say we got group, let's do the group 8/0, so that you can call it either. And then period 2. So group 8/0 is this one here. And then period 2, 1, 2. So this would be neon. Now if we want to know a little bit more about why they're put into those groups, so why, for example, lithium, sodium, potassium, rubidium, cesium and francium are all in group 1, we've got to start looking at the structure of the atom again and how the electrons are arranged. So if I pick, I'll tell you the rules first. So electrons, we already know they're arranged in shells. Now there's some rules about the shells that help you to arrange them. You might have seen in previous examples me arranging the electrons in particular ways. So 2 electrons can go in the first shell. In fact, let me speed this up. Okay, so I try to speed it up a little bit. Here are the rules. So you can put 2 electrons in the first shell. So that's the innermost shell. You can put 8 electrons in the second shell, 8 electrons in the third shell, and then any electrons you've got left over can go into the fourth shell. So if we pick an example, something like sodium, so this is the symbol for sodium on the periodic table. So there's sodium 11, 23 Na. Protons, electrons, neutrons, 11 protons, same number for electrons, and then 23 minus 11 gives us 12 neutrons. So I'm not going to draw the nucleus. We know in the nucleus they'd have 11 pluses and it would have 12 of the neutrons which are neutral. We're going to look at the electrons this time. So that's the innermost shell, and we've said in the innermost shell a maximum of 2 electrons. So we've got 11 in total to use. We can put 2 in the innermost shell. So we tend to use crosses to represent the electrons in these sorts of diagrams. So 2 in the first shell. In the second shell we can put 8, so there's the 8 in the second shell. And then in the third shell, so we've got 2 plus 8 gives us 10, we've got 1 more, so in the third shell we've got 1 more electron. Let's do another example. So if we pick magnesium, 24, 12, looks like that, PEN, 12, 12, and then 24 minus 12 is 12, so we've got 12 electrons. So 2 go in the first shell, 8 can go in the second shell, so we've used 10 so far, and then we've got 2 left, so there's our 12, 2 going into the third shell. Now that's one way of writing these sorts of things. You can shorten it, so you can do this shorthand version, which is to say 2 in the first shell, comma 8 in the second shell, and then comma 1 in the third shell. Do the same for this one, 2, comma 8, comma 2. So you can use, you might be asked to use either of those two systems. Things we can draw out of this a little bit then is that for any atom in group 1, so all the atoms in group 1, all of these guys, have all got 1 electron in outer shell. So if you look at sodium, sodium was in group 1. It's got 2, 8, and then in its outermost shell it's got 1 electron. If something was in group 2, so if we move to group 2, it's going to have 2 electrons in its outer shell. So I picked magnesium as group 2. You can see for magnesium it's got 2 electrons in its outer shell. So same story for the rest of them then. This series of atoms here have all got 3 electrons in their outer shell. In group 5, all 5 electrons in their outer shell. Group 7, all 7 electrons in their outer shell. And group 0 or group 8, this is why I prefer to call it group 8, have all got 8 electrons in their outer shell. So let's just pick an example to show you. Let's do neon, so 10, 20 Ne. Protons, electrons, neutrons. So it's in group A. I predict that it's got 8 electrons in its outer shell. 10, 10, and then 20 minus 10 is 10. So that would mean 2 go in the first shell, and in the second shell we can put 8, like that. So it would be 2, 8 for the shorthand version. So group 8, 8 electrons in the outside shell. So that's one thing we can draw out of it. The other thing, so we've looked at a bit more about why they're arranged in groups now. So the groups are because they all react in a similar way, and also because they've got the same number of electrons in their outside shell. Why are they put in these certain periods then? So the period, if I pick another colour, the period, so if it's in period 1, it's because it has 1 shell in total. If it's in period 2, it's because in total it has 2 shells. If it's in period 3, 3 shells, and so on. So if we pick an example, let's do one of these examples that I've already done. So sodium, if we look at sodium, there's period 1, period 2, sodium's in period 3. Based on the rules, so period 1, 1 shell, period 2, 2 shell, based on the rules, sodium should have 3 shells. It should also have 1 electron in its outside shell. So 3 shells and 1 electron in the outside shell. Sodium, 1, 2, 3 shells, 1 electron in the outside shell. So 1, 2, 3, and then the 1 in the outside shell. Did magnesium earlier, so magnesium, period 3, 1, 2, 3, and then it's in group 2. So it should have 3 shells and 2 electrons in the outside. 1, 2, 3 shells, 2 electrons in the outside. If we do neon, so neon is in period 1, 2, so there's neon, and group 8, so 2 shells, 8 electrons in the outside shell. 2 shells, 8 electrons in the outside shell. So that's how it's arranged, that's why it's structured this way. So well done if you got all the way to the end of this video. These are some of the most important concepts and the key concepts. So if you can get your head around these ideas, they're going to be used all the time and you're going to keep coming back to them. So I would make sure if those bits you didn't get, that you go back and you have a look through the video to try and get your head around them, or maybe even have a look through your book and try and see from that.